Alright, in this test I will look how few markers can be used with the Sermoon S1 in cross-line laser mode, since the depth of field of the scanner is at 600 millimeters. It should be better than with the Matrix. Sadly, I sold my Matrix, so I cannot do this comparison. For context, this area is 60 centimeters wide and 115 centimeters in length. So if any of you has the Matrix, you can compare it by yourself. If you look at the PC, I already generated a global marker file and will now continue with the point cloud scan. I will also capture the PC view so you don't have to look at the wobbly smartphone video. I had to recapture the global marker file since I sadly didn't save it, but as you can see in this better view of the scanning process, the scanner is quite okay with the marker spacing. Sometimes it loses tracking when being placed at the extreme points with a lot of space between markers. But then one trick that works quite well is tilting the scanner slightly so it can see more markers to the side. This of course works way better using marker geometries. When processing the data, I also cut out the fusion process. Now looking at the scan result, we can see I managed to capture nearly all of the table with the set marker density. But I guess I should have been a bit more patient and captured more frames, since you can still see remnants of the laser crosses. It could also be due to a too high exposure, but for the simple goal of testing the marker spacing, it is sufficient. When we now measure the spacing of the markers in real life, the marker geometries are somewhere between, here we have 19 centimeters, 18 centimeters, 21 centimeters, 22 centimeters. For the far ones, even 25 centimeters nearly. I guess it's somewhere between 15 and 25 centimeters. And for the higher distance of 25 centimeters, it's at the limit of what the scanner can do, especially while scanning. During capturing global marker, I have the feeling it can be spaced a bit more, but I would say 21 centimeters is the sweet point for the maximum distance. Of course, a higher density of markers is better, or provides a better scanning result, since more markers are in the optimal distance.